In this video, we're going to look at how to calculate volumes of revolution. Now, there's actually two different formulae for calculating the volume of revolution, depending on how we're rotating our curve. So in the first example, we're going to be rotating a curve about the x-axis, and the formula is the volume of revolution is V is the integral of pi times y squared dx. So that's for a rotation around the x-axis. If you think about our diagram, we're sort of rotating around this axis here. Okay, so it's pretty straightforward. You just plug our formula, our equation into the formula. So in our example, we have to rotate this curve y equals e to the 3x plus 1 to the half. So our volume is the integral between the limits. So these limits a to the b are the limits of our curve on the x-axis. So in this case, it's 0 and 2, multiplied by pi, multiplied by y squared. Well, y squared is e to the 3x plus 1 to the half squared. Well, that just gives the integral between 2 and 0 of pi, or e to the 3x plus 1. The power of the half and the power squared sort of cancel one another out. Remember, this is integral with respect to x, which is, well, pi is a constant. The integral of e to the 3x is 1/3 e to the 3x. The integral of 1 is plus x. And again, it's between 0 and 2. And now we can work out the upper limit gives pi 1/3 e to the 3 times 2 is e to the 6 plus 2. And the lower limit, we're going to take away pi times 1/3 e to the 0 plus 0. Well, that's, well, e to the 0 is just 1. So you get pi over 3 e to the 6 plus 2 pi minus 1/3 pi. We did a little bit of cancellation. So that's equal to, and we can take pi out as a factor. So I think we get pi, actually pi over 3 e to the 6 plus 5. We've taken pi over 3 out as a factor. And that gives, if you want to be exact, or an approximate answer, that's 427.71. So that's finding the volume of revolution rotating a curve around the x-axis. We'll have another example, which is where we rotate a curve about the y-axis, and it's pretty similar. We just have a slightly different formula with sort of the x and y's interchanged. So now to rotate about the y-axis, our volume is now the integral of pi x squared dy. Remember, before it was pi y squared dx, now it's pi x squared dy, and that's for rotation about the x-axis, about the y-axis. So in our example, we can think of sort of rotating around this axis here. So let's do this example, rotating on the y-axis. We have to work out, we need to know what x squared is. Well, in our case, we have y equals the square root of 100 minus 4x squared. But that's, so we need to rearrange this in order to get what x squared is. If we square both sides, we get y squared equals 100 minus 4x squared. A bit of rearranging gives x squared equals 100 minus y squared over 4. Okay, so now we can plug this into our formula for V. So V equals, well, it's the integral between C and D. Now, C and D are the values on the y-axis. So it's asked 0 and 10 numbers. Make sure you get that right. It's the numbers on the y-axis in this case. 0 and 10 times pi times the integral of times x squared. Well, x squared we worked out was 100 minus y squared over 4. And we're going to integrate this with respect to y. Okay, so let's just do this integral. We get pi 100 over 4 gives, well, we can take pi over 4 out as a factor, and then we get 100y, then y squared integrates to give y cubed over 3. Between 10 and 0. Okay, and substituting the upper limit, I get pi over 4. 100 times 10 is 1,000. 10 cubed over 3 is minus 1,000 over 3. And then the 0 lower limit, well, when you substitute that in, you just get zeros everywhere. So you don't have to worry about that. And this just simplifies down, I think, to 500 pi. Yeah, just a little bit of rearrangement. We'll make that into 500 pi over 3, which is an answer in terms of pi, which was what was asked for in this specific question.